So hello everyone, welcome to your favorite YouTube channel BYJU'S Exam Prep. I am Deepak Mishra and in this class we'll discuss most important question in compiler design. And I will also tell the concept also. Along with the question we'll discuss the concept so that you can solve question in an easy way. Okay, and this class will be in English, so I will use Hindi and English also. If you are comfortable in Hindi, please let me know also. And if you are comfortable in English also, please let me know. Okay, so I'm starting the class. So this is my Telegram channel. Find my dear friend for daily dose to improve your concepts, for daily notification of the class, important PDF. If you have any query regarding GATE, computer science or GATE data science and AI, you can ask me. I will definitely help you. So UPSC ESE 2023 mains exam result out हो चुके हैं. Fine. You can share your result. If you have any friend जिन्होंने UPSC ESE क्वालिफाई किया इस साल, अपना आप रिजल्ट शेयर कर सकते हैं. और फ्री मॉक इंटरव्यू विद आवर एक्सपर्ट पैनल ये अभी शुरू हो चुके हैं. बहुत लोग आ रहे हैं. फाइन. और डेफिनेटली आपको बहुत इसमें हेल्प मिलने वाली है, तो यू कैन शेयर एज मच एज पॉसिबल. सो या now I'm starting with a question. Fine. In lexical analyzer mostly they will ask question from like how many tokens are there, like fine, and maybe they will ask question from the phases of compiler also, so I will discuss in this class. So yeah, this is the very first question. Please try everyone. This is very easy one. Fine. Step by step we will move. Fine. This is question number 1, my dear friend. They are asking about number of tokens in the following C statement. Print F. Fine, my dear friend. And they have given, you can say like in this function we have 3 arguments. Like see, you can say this one is first one, then I, then n%i. Fine. And they are asking the number of tokens. Fine. So I think everyone know what is the first phase of compiler. What is the first phase of compiler? Fine, it is nothing but lexical analyzer. Fine, it is nothing but lexical analyzer. Everyone know. So first phase of compiler is nothing but lexical analyzer. So what lexical analyzer will do? It will take pure high level language. You can say pure high level language means you can say like there is no preprocessors. Fine, we already pre-processed. Fine, so there is no preprocessors. Only we have characters. Fine. What lexical analyzer will do, it will scan your program from the very beginning, and go till the end. Fine, it will scan your program from the very beginning and goes till the end. And it will produce what? It will produce a stream of tokens. It will produce, my dear friend, a stream of tokens, my dear friend, a stream of tokens. Okay, stream of tokens. Okay. So what is the functionality of lexical analyzer? Let me tell you also. So lexical analyzer की functionality क्या होती है? ये क्या करेगा? आपके प्रोग्राम को शुरू से लेके एंड तक क्या करेगा? स्कैन करेगा. इसीलिए इसको हम स्कैनर भी बोलते हैं. अगर कोई भी व्हाइट स्पेस है या कोई भी टैब है तो उसे क्या करेगा? उसे रिकॉग्नाइज करेगा. उसके बाद क्या करेगा? उसे इग्नोर कर देगा. फाइन, या इग्नोर कर देगा, या आप कह सकते हैं डिलीट कर देगा. फर्स्ट इट विल रिकॉग्नाइज, ओके, व्हाइट स्पेस इज देयर, tab is there. It will recognize and what? Ignore it or delete it, whatever you can say. Fine. Now the next point, it will always matches the longest prefix. It will always matches the longest prefix, my dear friend. Longest prefix. Are you getting my point? Okay. So what are the tokens might be you have already know. Let me tell you also. Tokens are nothing but these are keywords. किसको you can just आप याद कर सकते हैं किसको. So keywords. K for keywords, I for identifier, S for special symbol, C for constant, and O for operator. O for what? Operator. So what we have? We have keyword, we have identifier, we have what? Special symbol, we have what? Constant, we have what? Operator. You can write S, else also, string also if you want. Fine. So my dear friend, in this question they have asked, see clearly here. So see here. So it will scan from the very beginning. So this particular C statement will meet to the lexical analyzer. What lexical analyzer will do? It will what? It will give a stream of tokens. See here. So printf. So now I think printf is an identifier. So this is ID1, identifier. Fine. Printf is an identifier. Good evening, Satya. So printf is an identifier. What about this one, my dear friend? This is nothing but you can say special symbol. So SP1 I am writing. SP1. Fine, SP1. Now see here. Double quotes. See here. Double quotes starting from here till here. Till here, my dear friend, it will nothing but it will be a one token. Fine, it will be a one string. See, double quotes. It will be considered as a single token. See clearly 1, 2, and now we have 3. Fine. 3. Now comma, it is also, you can say, special symbol. Let me say special symbol 2. Mine. Let I is what? Identifier. I is what? Identifier. So identifier number what? 2. Comma is nothing but separator. You can write a special symbol 3. And percent, my dear friend, you can say it is operator. So nothing but you can say OP1. Okay. Now I, what is, once again it is identifier. Identifier. It is nothing but ID3. Now this is nothing but a special symbol. So SP4 I am writing here. This is nothing but separator, or you can say special symbol SP5 I am writing. SP5 I am writing. Are you getting my point? So how many tokens are there if you see clearly? So see clearly. I am counting here. 1, 2, fine. This is nothing but 3, 4, 5, 6, 7, 8, 9, and 10. So we have how many tokens here? Here we have 10 tokens in the program. 10. So C is the right answer for this one. Yeah, C is the right answer for this one. See, C is the right answer for this one. So what lexical analyzer will do, my dear friend? It will scan from the very beginning and goes till the end. Fine. It will see here what is printf. Printf is a function. It is an identifier. So this is nothing but one token, identifier 1. Then we have what? Separator, SP1. Then we can say we have a string. You can write a string. Fine. So this is nothing but third token. In double quotes, whatever come, it will consider as a string constant. It is third one. Now comma is a separator, or you can say special symbol. Fine. I is identifier. Comma is separator or special symbol. And percent. I, closing bracket. And my dear friend, semicolon. So here we have how many tokens? 10 tokens. Sir, how they have given 3? 3 kaise diya hua hai? See here. Maybe 3 arguments are there. That's why they have given 3 as answer. Maybe. Fine. See clearly, sir, how they have given, sir, 26. I think if you count, see, if you count each thing, it will counting is nothing but 26 only. That's why they have given 26. Sir, how they have given 21? 21 maybe. If printf you can count as a 1. Rest if you count as a single character, it will give you 21 also. So like that they have given, but you should know you should have very good idea about this, then you are able to say the answer. Okay. Can you please let me know, my dear friend? See clearly here. See clearly. Let me tell you, already I have written here. Lexical Analyzer scans the source code and divides them into the words. And if these words are accepted by finite automata, then they are called token. Fine. Then they are called token. Fine. Actually, it is called, see, internally it is called lexeme. This is nothing but lexeme, my dear friend. Lexeme. Fine. And what compiler will say? It is nothing but token. You know, int is nothing but, int is a keyword. Fine. Int is what? Keyword. It is a keyword, my dear friend. Keyword. X is what? Identifier. This is what? Operator. This is what? Constant. And this is what, my dear friend? You can say special symbol. So here, how many tokens we have? 1, 2, 3, 4, 5. Here we have 5 tokens. So see here, it is actually lexemes. And internally, say, compiler will say it is nothing but token. So keyword is 1 token, identifier is 1 token, operator is 1 token, fine, constant is 1 token, and special symbol is another token. Fine. The output will not look like this. The output will be like this. See here, we have keyword 1. Let's suppose key 1. Fine. We have what? Identifier 1, ID 1. We have what? Operator 1. We have what? Constant 1. And what we have? Special symbol 1. So there is no space at all also. Fine. And with the help of what? With the help of DFA, with the help of finite automata, we are able to generate a token. I think everyone know L followed by letter plus digit closure. Fine. This is the regular expression. Fine. So with the help of finite automata, we are able to generate the tokens. Fine. Okay. See here. Now, see clearly here. The sequence of character with logical meaning is a token. Fine. And a token is an atomic programming unit. That is a token that can be split into the smaller ones. So token describe the class category of input string of, for examples, we have identifier, keyword, constant. Fine. Like here I have clearly mentioned what is lexeme and what is token. Already I told you about this. Okay. Now, many people have slight confusion. Let me ask you, my dear friend, how many tokens here? Can you please tell me? X equal to plus y. Can you please tell me, semicolon, how many tokens in this one? Can anyone say how many tokens? How many tokens are here? Anyone say? Please reply fast. How many tokens are it? How many tokens are there? See clearly. Here, see, this is 1 token. I'm counting only. I'm not writing identifier and all. 1 token. This is nothing but 2. Fine. Longest prefix will be matched. This is nothing but 3. This is nothing but 4. This is nothing but 5. See, plus is already a token. But see here, longest prefix only you can match. So plus plus you will consider as a single token. Fine. Plus 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 you can consider as a single token. Okay. Can anyone say how many tokens here? Int pointer star star p. Can you please tell me how many tokens are there? Int star star p. How many tokens are there? Int star star p. Second one, can you please say how many tokens are there? So here we have 5 tokens. Here we have 5 tokens, my dear friend. Can you please tell me about next one? Int star star p. How many tokens are there? Int star star p. How many tokens are there? Fine. Third one. Let me tell you how many tokens are there. See, integer, you know, it is a keyword. 1 token. 1 token, my dear friend. 1 token. What about this one? See, star. It is nothing but one operator. OP1. This is nothing but OP2. This is nothing but identifier. ID3. This ID2. Oh, sorry, ID1 only. ID1. And this is nothing but what? Special symbol or separator, whatever you can say. So how many tokens we have? 1, 2, 3, 4, 5. Here also we have 5 tokens. Here also we have 5 tokens. Is that clear, my dear friend? Here also we have 5 tokens. See, int 1 token. See, star. This is see here. This will consider as an operator 1 token. No. See, many people do mistake. Like they will count this one is a single token. It is wrong actually. It is wrong. See, this one is this will consider as a single token. This one is a single token. P is a single token. Now what we have? We have identifier. So here also we have 5 token. 1, 2, 3, 4, 5. We have 5 token, my dear friend. Fine. 5 token. See, I am writing here 1, 2, 3, 4, 5 token. Okay. Maybe see here, if it is like this plus 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 a, how many tokens are there? Now you can say plus 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 a. So how many tokens are there? See clearly. So this is nothing but 1 token. Longest prefix, you know, plus plus. Fine. This is nothing but second token. This is nothing but third token. This is nothing but 4 tokens. So here, how many tokens we have? We have 4 token here. Here we have 4 token. Here we have 4 token, my dear friend. Here we have what? 4 token. Are you getting my point? So see, some examples you should know, like don't do wrong. Fine. Don't do wrong, my dear friend. Fine. Let's suppose if any preprocessors they have written, fine, in the program. Fine. Preprocessors, my dear friend, it is already preprocessed by what? Preprocessor. Fine. So there is no, don't count preprocessors. Fine. It will start from what? Let me write. If I will write like this. Let's suppose if I will write as include whatever. Include or maybe okay. Okay, you can skip as of now. Fine. Maybe I think what you got my point. If I will write preprocessors, fine, my dear friend, don't count it. Fine. Always start from after the preprocessor, because you know Lexical Analyser will meet to the pure high level language. It does not have any preprocessor. It have only characters, you can say. Okay. Now, can you please tell me, everyone? Yeah. Let me ask you one more question. This one. Sorry. Let me. I think it is 50. A of 50. How many tokens are there? Can you please tell me? A of 50. How many tokens are there? How many tokens are there here? Can you please reply, everyone? Can you please reply? Everyone. Or let me write here. Next one. How many tokens are there? Let me write 7th one. How many tokens are there? Can you please reply? How many tokens in 5, 6, and 7? I am waiting for your answer. Please reply, everyone. How many tokens? In 5, 6, and 7, I am asking. Please do fast so that we can move to the next question. Okay, Krishna Rao is telling 5. 5. Okay. See clearly. Okay. See, I'm starting here. See clearly, my dear friend. Can you please tell me? See. 5 is 5. Okay. 5 is 5, my dear friend. 5 is 5. Okay. See clearly here. See, my dear friend, these 3 are what? Loopholes. Actually, loopholes in what? You cannot able to count with the help of Lexical Analyser. Fine. So there is a need of syntax analyzer also. So there is a loophole. Fine. You are not able to find out with the help of only Lexical Analyzer. There is a need of syntax analyzer also. So here we have, you can count this one is a single token. This one is a single token. This is only 1 token, my dear friend. 1 token. Fine. This one is 1 token. This one is what? 1 token. Short circuiting. Fine. You know, this is considered as a 1 token. 1 single token. and this one size of this one consider as a one token. Find one token. So only see here only we have what? We have loophole, you can say. We are not able to find out with the help of lexical analyzer. There is a need of syntax analyzer if we want to find the token. अगर हमें token find out करना है तो यहाँ पे syntax analyzer की भी जरूरत होगी. तो इसमें कितने टोकन होंगे देखो. How many token we have? 1 2 3. So we have 1 2 3 4. Here we have 4 token. 4 token. Is that clear, my dear friend? We have 4 token. So this is 1, this is 2, this is 3, this is 4. So we have 4 token in the very first one. In second one we have 1 2 3 and 4 and 5. So in second one we have how many token? 5 token. 5 token. In third one we have, my dear friend, we have 1 2 3. We have 3 token. Is that clear, everyone? Please you can write. See these 3 examples. No, see here, token is continuous, yes, but I told you very clearly that is a loophole. With the help of lexical analyzer, my dear friend, you are not able to find these 3 tokens. Fine, you cannot tokenize this. Actually, you are not able to tokenize this. There is a need of syntax analyzer also. With the help of that only you are able to find out the token. Fine, these are only 3 loopholes you can remember. Maybe in exam they will ask. So you can consider this one is a single token. This one is a single token. I think you know also, find this one. Short circuiting, everyone know how it will work. Okay, and this one will be considered as a single token. Okay, is that clear, everyone? Please reply. Okay, I'm moving now. I'm moving to next question. Okay, can you please try this question? Can you please try? Consider line number 3 of the following C program. Fine, and they have asked identify the compiler's response about these lines while creating the object module. Can you please tell me the answer? Can you please tell me the answer correctly, my dear friend? Please reply. I'm waiting for the answer. Option A, no compilation error. Option B, only a lexical error. Option C, only syntactic error. Option D, both lexical and syntactic error. What is the answer? Can you please let me know? See, in case of lexical analyzer, I told you very clearly, it will take character and produce a stream of tokens. Tokens is nothing but Kisco. Kisco means keyword, identifier, special symbol, constant and operators, my dear friend. Okay, it will recognize tab, it will recognize white space and what? Delete it. It will ignore comment. It will what? Ignore comment, my dear friend. It will ignore comment. Everyone, I think, no. Fine. It will what, my dear friend? Scan from the very beginning until the end. That's why it is also called a scanner. That's why it is also called a scanner, my dear friend. So someone telling option D, someone telling option C, my dear friend. See clearly here. See, they are asking about line number 3. Fine, in following C program, line number 3, my dear friend, identifying the compiler response about this line while creating the object module. So, my dear friend, see here, can you find a number of tokens here? Can you find a number of tokens here? No, throw is not an error, my dear friend. Throw is not an error. It will consider as a function. It will consider as a function, my dear friend. Fine, it will consider as a function. Are you getting my point? In function, we have what? It will take, like in function, we have 3 arguments. In function, maybe by default, actually they want to write for, but they have written unfortunately fro. Actually, intentionally they have written. They want to test your knowledge, my dear friend. But see here, fro, it will consider as a function. It will consider as a function. If you find a number of tokens, see int, it is a keyword, 1 token, 2 token, 3 token, 4 token. Fine, this one ignore. Fine. Now, actually it is a comment only. It will ignore, multi-line comment. This is 5 token, 6 token, 7 token, 8 token, 9 token. Fine, 10 token, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, fine, 21, 22, 23, 24. We have 24 tokens here. Definitely you are able to tokenize. Fine. See, if there is any lexical error, you are not able to tokenize. Fine. अगर error है, अगर कोई lexical error है, तो आप tokens find out नहीं कर पाओगे program के अंदर. Let's suppose if I will write like this, int 1abc. Fine. Can you find a number of token here? Can you find a number of token here, my dear friend? Can you please tell me? Can you find a number of token? No. It is not a valid identifier. Fine. See here, it is not a valid identifier. Identifier will be start from either, alphabet or underscore, So it is not a valid identifier. So it will give lexical error. So here you cannot count the number of tokens. You are not able to count the number of tokens. My dear friend, if there is any lexical error, please don't count tokens. Please don't count tokens. Fine. If lexical error is there, अगर lexical error है तो token count नहीं करना है. ठीक है. अब यहाँ देखो, ये बोल रहा है आइडेंटिफाई द कंपाइलर रिस्पॉन्स। तो अगर आप इस कोड को रन करोगे, जो फ्लो है वो एज अ फंक्शन वर्क करेगा, इट विल वर्क एज अ फंक्शन, सो इट विल गिव लिंकिंग एरर, इट विल गिव वार्निंग टू यू, फाइन, वो आपको वार्निंग देगा, इट विल गिव वार्निंग, इट विल नॉट गिव एनी काइंड ऑफ एरर, इवन दो इन गेट ऑप्शन it has been written compiler error. In gate option they have written compiler error, but here I have changed no compilation error because it will give warning. So that's why answer A is correct. That's why answer A is correct. It is not lexical error. It is not lexical error, my dear friend. Are you getting my point? It is not lexical error. Is that clear? Fine. Lexical error, maybe it is like this, not valid identifier. Maybe like opening. Let's suppose like this, like starting comma, but ending comma is not there. Then it will give lexical error. Might be. Fine. Are you getting my point? It will give lexical error. But here it will not give lexical error. Fine. So this is wrong. This is also wrong. This is also wrong. Fine. Because no syntactic error here. Okay. I'm moving now. I think it is clear to everyone. Okay. Now, which data structure is compiler is used for managing information about variable and their attributes? Which data structure is compiler is used for managing information about variables and their attributes? Yes, you told only. Yes, Shatya. Can you please tell me what is the answer for this one? Okay. Answer is what? B. Yes, B is the correct answer. Yes, everyone. I think symbol table आपको मालूम है, symbol table क्या data structure है, और सारे phases of compiler से क्या होता है, वो connect होता है. All phases of compiler से क्या होता है, connect होता है. Fine. I think everyone knows. So here I have written also the symbol table is a data structure created by the compiler to store the complete information of the source code. Fine. And at each and every phase, if any new variable is encountered, it is stored into the symbol table. Into the what? Symbol table. Symbol table को आप implement कर सकते हैं, tree की help से implement कर सकते हैं, hash की help से implement कर सकते हैं. Fine. I think you know, like various data structure are available to implement symbol table. During the first two phases of the information is stored into the symbol table. And in the remaining phases, we have make use of the information available into the symbol table. Fine. And lexical analysis is the first phase in the compilation. During the lexical analysis phase, the symbol table structure is created. I think you know this concept. Only for your awareness, I have written. Okay, I'm moving now. Okay. Can you please tell me, in a compiler, keywords of a language are recognized during? I think you know, this is very easy question. Keywords of a language are recognized during. What is the answer? What is the answer, my dear friend? What is the answer? Can you please tell fast? Fine. I think everyone know. Answer will be what? For this one, what will be the answer? Data flow analysis we will use for optimization. It will not be the answer. Fine. You know. Parsing of the program we'll use for what? To generate what? Syntax tree. So answer will be what? Yes, C. The lexical analysis of the program. Everyone know. This is the right answer. C is the correct answer. C is the correct answer. I think everyone know. Like डेटा फ्लो एनालिसिस हम कहाँ यूज करते हैं? फाइन. पार्सिंग ऑफ द प्रोग्राम आप कहाँ यूज करते हैं? डेटा फ्लो एनालिसिस कहाँ पे यूज करते हैं? ऑप्टिमाइजेशन ऑफ द प्रोग्राम, कोड ऑप्टिमाइजेशन के अंदर हम यूज करते हैं. पार्सिंग ऑफ द प्रोग्राम, माय डियर फ्रेंड, हम क्या करते हैं जब भी हमें क्या करना है? पार्स ट्री जनरेट करना होता है. फाइन. कीवर्ड के लिए क्या होगा हमारा? लेक्सिकल एनालिसिस ऑफ द प्रोग्राम यूज होगा, डीएफए यूज होगा, या आप कह सकते हैं फाइनाइट ऑटोमेटा यूज होगा. ओके. दिस क्वेश्चन, कैन यू प्लीज टेल मी, the lexical analysis for a modern computer language such as Java needs the power of which one of the following machine models in a necessary and sufficient sense? They're asking the lexical analysis of a modern computer language such as Java, fine, or you can say Python, needs to power of which one of the following machine models is necessary and sufficient sense? Can you please tell me? Lexical analysis के लिए कौन सा इसमें sufficient और necessary है? Can you please tell me? Yes, I think everyone give. I think yes, A is the right answer. Yes, finite state automata, my dear friend. Yes, finite state automata is my dear friend. It is sufficient for this one. Fine, is sufficient for this one. Even though see necessary and sufficient for this one. Turing machine, or you can say deterministic push-down automata. Fine, deterministic push-down automata or non-deterministic push-down automata. You can say PDA and NPDA. PDA, and this is nothing but NPDA, my dear friend. This is Turing machine. It is more than sufficient. It is more than. No, it is not. It is not, my dear friend. It is not PDA. Push-down automata, my dear friend. See, actually, finite state automata, my dear friend, they're asking necessary and sufficient. I think, see, you know, lexical analysis के लिए we know what we want. We want regular expression. Regular expression के लिए हम क्या कर सकते हैं? We can make DFA. So DFA is more than sufficient. DFA is necessary and sufficient. But if you talk about PDA, NPDA, and Turing machine, it is what? It is not more than sufficient. More than sufficient for this. They ask only necessary and sufficient. So for lexical analysis, I think, finite state automata is necessary and sufficient. Fine. This one is more than, this one is more than sufficient, my dear friend. Either PDA, NPDA or Turing machine. So that's why the correct answer will be what? Finite state automata. Finite state automata. Fine. Okay. Let me move to the next question. Yeah. Now they have asked this question, my dear friend. It is also easy one. Match the following according to the input from left column to the compiler phases in the right column that process it. Fine. If you know the phases of compiler, you are able to give the answer. Fine. What is the answer for this one? Can you please reply? You can see the options. Fine. And you are able to give the answer. See the question. Read the question carefully. Fine. Match the following according to the input from the left column. Input from the left column to the compiler phase. And right column is nothing but the output. Can you please tell me? What is the answer? Yes. Yes, very good. Answer is C. Yes, everyone know. See clearly here. Syntax tree. Syntax tree is what? Everyone know. It is the output of what? Syntax analyzer. Fine. Syntax analyzer. Okay, option D is not visible. Okay, option D is not visible. Okay, I will take care of this next one. I think option D I'm writing here if you want. P first, Q fourth, and R second, and S third. This is option fourth. Fine, this is option fourth. Okay, my dear friends, see clearly. Syntax tree is output of what? Syntax tree or parse tree you can say. It is output of what? Syntax analyzer. Syntax analyzer. So what is the input? I think input for semantic analyzer. So P third. So if you see P third, here it is an option only in I think C. It is only in C, P third. I think no need to solve this question. Fine. But yeah, you should know about this one. Syntax tree is what? Is the input for semantic analyzer. Semantic analyzer. Fine. Character stream is the input for what? Lexical analyzer. I told you very clearly. Fourth one. Character stream is nothing but it is the input for the lexical analyzer. Intermediate representation. It is the input for what? It is the input for code generator. Code generator. And token stream is the input for what? Syntax analyzer. Syntax analyzer. Fine. Token stream is the input for what? Syntax analyzer. Fine. This is also easy question. If you know the phases of compiler, you are able to give the answer. See clearly here. This is the phases of compiler. Fine. We have lexical analysis. We have syntax analysis. We have semantic analysis. We have intermediate code generator, code optimization, code generation. Fine. So till here, what we have, it is a front end of the compiler, and this is nothing but back end of the compiler. Fine. Front end and back end. So for one front end, we can design many backends. And see, all phases of a compiler will connect it to the symbol table and error handler. Okay. So based on that, also they have asked one question. I will ask you. Okay. Can you please tell me what is the answer for this one? What is the answer for this one? Match the following. Directly they have asked. What is the answer for this one? Match the following. D option I am writing here. It is not visible, I think. D is P4, Q first, R second, and S third. Can you please tell me what is the answer for this one? Everyone. Match the following. Lexical analysis, my dear friend. Can you please let me know? Lexical analysis. Yeah, it is nothing but, my dear friend, I think everyone know. Regular expression. Fine, regular expression. Fine, with the help of regular expression, with the help of finite automata, we are able to generate streams of token. Now, top-down parser, I think everyone know. It is what? Leftmost derivation. Top-down parser will start from the top and goes to the leaf. Fine, and it is nothing but leftmost derivation. Leftmost derivation. See clearly. So P is third. P is third, my dear friend. See clearly, P is third. Lexical analysis is what? Regular expression. Top down is what? Leftmost derivation. How D, my dear friend? Satya, how D is the answer? Fine. Semantic analysis. It is nothing but for type checking. For type checking, my dear friend. Semantic analysis is for type checking. And runtime environment for activation record. Runtime environment for activation record. So if you see, P is what? P is third. So P is third. I think they have given in one option only. P is third. P is third. Q is what? First. Q is first. R is what? Second. R is second. R is second. Fine. And S is fourth. So B for Bombay is the correct answer. B for Bombay is the correct answer for this one. Is that clear, everyone? Lexical analysis, my dear friend. What do you want? Regular expression only, na? With the help of finite automata, you are able to generate streams of token, my dear friend. Okay. Top-down parser, it is a leftmost derivation. Everyone know. Fine. Semantic analysis, type checking we do. We do type checking in semantic analysis phase. Fine. And runtime environment, my dear friend, we manage activation record in the form of stacks. Okay. Okay. No problem. No issue. But yeah, please don't do in the exam. Please don't do in the exam. Okay. You can try this one. This group 1 and group 2. Such kind of question they will ask in Lexical Analyzer. In next class, definitely some good question also come. But this is also good question. People do mistake. Silly mistake. Fine. Okay. Can you please tell me what is the answer for this one? Regular expression, I think. Everyone know. Lexical analysis. Fine. Okay. Now push down automata. Push down automata, my dear friend. I think PDA for syntax analysis. For CFG, we have what? Push down automata. We have what? PDA. Okay. And data flow analysis, my dear friend, for code optimization. And register allocation for code generation. Fine. Code generation. So what is the answer for this one? Yes. P is 3. Q is 1. R is 4. R is 4. So R is 4. P is 3. Q is 1. R is 4. And S is what? 2. S is what? 2. Okay. So B for Bombay is the correct answer. B for Bombay is the correct answer. Okay. B for Bombay is the correct answer. Is that clear? Yes. B for Bombay is the correct answer. Now, tell me, match the following. Fine. Match the following. This question they have asked also, like in GATE 2015, my dear friend, match the following. So see here, such type of question, if you don't know also, now what you do, you are like with the help of option, you are able to give the answer. With the help of option, you are able to give the answer. Okay. Can you please tell me? So lexical analysis, everyone know. DFA minimization. So P is 2. So I think P everywhere P is 2. Okay. Parsing. Parsing is nothing but, production tree. So Q is 4. Now Q is 4 is matching is here only. See clearly P is 2 and Q is 4. It is matching is here only. Option is, I think problem is over. Now if you see here, our register allocation is nothing but for huge. See, and expression evaluation for post-order traversal only. Everyone know in stack we do. Fine. So that's why this S is 3. Now this one will map to this one 1. So I think, answer will be what? C. C for Chennai. P2, Q4, R is 1 and S is what? 3. Yes. So C for Chennai is the right answer for this one. Okay. Yeah. Now see clearly this question, my dear friend. Can you please try this question? This question once again, it is what? Based on longest prefix only. Longest prefix. So till now in Lexical Analyzer, ये सबसे अच्छा question था. They have mixed both TOC and whether you are able to find number of tokens or not. Can you please tell me? The meaning of this one is, I think you read the question, I think. Please read the question. The meaning of this one is nothing but, they have written here, X question mark means 0 or 1 occurrence of the symbol X. Fine. So you can write like this also, like B oblique C, B plus C claim closure, B or C claim closure A. Or you can write, it will start from A, or you can write B oblique C claim closure A. Claim closure A. What about this one? You can write here A oblique C claim closure B, or you can write here B, fine, and A oblique C claim closure B. Fine. Third one you can write here, T3 you can write here, fine. You can write here B oblique A claim closure C, B oblique A claim closure C, my dear friend, plus you can write C, B oblique A claim closure C. Okay. So in this question they have asked about that X question mark means 0 or 1 occurrence of the symbol X. That's why I have written here. See here A is not there and here A is there. Fine. Now note also that the analyzer outputs the token that matches the longest prefix, even though they have written also the longest possible prefix. If the string, they have given the string here, BBAACABC is processed by analyzer, which of the following is the sequence token in the outputs? So they have given T1, T2, T3, T1, T1, T3, T2, T1, T3, and the D option they have given T3 and T3. Please try this one. D option they have given T3 and T3. Can you please tell me? Okay. if you take first option, let me write here. I'm writing here B, B, A, C, A, B, C. You should give the longest prefix matching, my dear friend. Longest prefix matching. If you, okay, someone telling A, someone telling A, someone telling, okay, I'm waiting for the options also. Please reply. Okay, see clearly here what we have. So see, so T1, T2, T3. So T1, if you see clearly here, so it is nothing but B, C, B or C clean closure A plus A, B oblique C clean closure A. So my dear friend, see clearly, can we generate, see T1, what we can generate? We can generate B, B, A. See, ending with A only, na? So with T1, we can generate this one. Are you agree? Can we generate C, B, B, A with the help of this one? B oblique C clean closure A. So we can generate double B means B, B, A with the help of this one. No problem. Now, what is next one? T2. So with the help of T2, my dear friend, see here what we have. See, we can generate what? A, can we generate what? A, C, my dear friend. A, C, A, B. Yes, we can generate. So T2, we can generate A, C, A, B. Is that clear, everyone? Please reply. Till here, if you have doubt, you can ask. Fine. And with the help of T3, can we generate C? Yes, we can generate C. T3, my dear friend. So this is nothing but T1, T2, T3. But longest prefix they are asking. So you can solve each and every option. So this is the first option. This is the first option. Are you getting my point? Now you can go for the second option. Second option I'm writing here. I think it is visible for everyone. Visible for everyone? It is visible here. Okay, I'm writing here. So what we have, my dear friend, we have B, A, C, A, B, C. I think it is visible. So now T1, my dear friend. T1, what I can generate? T1 I can generate here. I can generate BBA. So this is nothing but T1. BBA I can generate. T1. Now with the help of T1, once again we have T1. So T1, what we can generate? See here. We can generate here A, C and A. A, C and A. So I can generate T1. See T1. Now what we have? T3. So T3, can we generate BC? Yes. From here I can generate BC. B and C I can generate from here. From this part. Fine. So this is nothing but T3. So this is nothing but the second one. T1, T3. Now you can check for what? T2, T1, T3 also. See clearly, I am taking the string B, A, C, A, B, C. Now my dear friend, T2, my dear friend. See T2 here. What is T2? T2 is, can I use this one? No, I can use this one for this one. Fine. T2. So see here, B, what I want actually? I want T2. Okay, can I generate here? I can generate only B and B. So this is T2. B and B I can generate with the help of this one. B and B. Fine, B and B. Okay, is there any problem? Now T1, my dear friend, T1. Now we have T1. What we have? So okay, see here, A and A. So I can generate A and A with the help of T2. T1. Now what we have? T3, my dear friend, T3. So this is T3. So what I want C, A, B, C. So I can generate T3, this one. This is T3. Fine. So we have done T1, we have done A, B, and C. Now the terms of now T3 and T3. So let me take here B, A, C, A, B, C. See clearly here with the help of T3, my dear friend. Can you please let me know? T3. So what is T3? T3 is here only. So I can generate B, A, C. So till here I can generate T3 with the help of T3. B, A, C. Fine. Now once again T3 in option. So T3 in option. So I can I generate A, B, C? What we have? A, B, C. So yes, with the help of this one, A, B, and C, we can generate T1. Yes. T3. Fine. Now they have asked about, see here, longest prefix. You know, in Lexical Analyser, always go for the longest prefix. I already told in the class. Fine. See clearly here. So if you see clearly here we have what? 3 and the length is what? 4 and 1. What is the longest prefix if you see here? 1, 2, 3, 4, 5. This is the longest prefix, my dear friend. T3. See, this is the longest prefix that is matching. See here we have 1, 2, 3. Here what we have? 1, 2, 3. Here also what we have? 1, 2. Here we have 1, 2, 3, 4, 5. Longest prefix, my dear friend. The answer will be what? D for Delhi. Is that clear, everyone? D for Delhi is the right answer. T3 and T3 is the right answer. Is that clear? Please reply. Everyone. Is D for Delhi is clear? Clear hai? D for Delhi clear hai, my dear friend? Please reply. D for Delhi is clear. I am moving now. I think it is clear to everyone. Longest prefix, always longest prefix, my dear friend. Okay, like maybe in question they will ask, see, what is X left shift equal to Y? How many tokens are there? How many tokens are there? X left shift equal to Y. How many tokens are there? So many people do wrong. Longest prefix. See, 1. And this one we will consider as a single token. 2. We have 3 token here. We have 3 token here. Are you getting my point? We have 3 token. X, see, the left shift equal to Y. So left shift equal to, it will consider as a single token. Longest prefix we have to match. So in this question, they want actually whether you want some TOC and some CD concept or not. And with the help of that, whether you are able to find out longest prefix or not. Okay. Okay. I'm moving now. Which of the following statement is false? False they are asking. False they are asking, my dear friend. Which of one of the following statement is false? They are asking about false, my dear friend. Context-free grammar can be used to specify both lexical and syntax rules. Context-free grammar can be used to specify both lexical and syntax rule. Yes, it is true only. Fine. True only. Because any type 3 grammar is what? Type 2 grammar. Any type 3 grammar is what? Type 2 grammar. If any regular expression you can write with the help of context-free grammar only. So that one is true only. Fine. So this is true. A is true. But type checking is done before parsing? No. Type checking is done after parsing. Blindly you can say definitely, my dear friend, but here I need to analyze this one. Na? Fine. I will say blindly you can go with T3 and T3. Fine. 2 terms only, with the help of 2 terms you cannot say always, but yes, for looking the options, fine. See, T3 will go for the like longest prefix. Yeah, 2 terms contain all the prefix. Definitely, my dear friend, 1 will go for the longest one. Probably it may happen. Yes, you can go, but always it will not happen, my dear friend. Always it will not happen. Fine. It depends on like what regular expression they have given. Fine. So according to this one, maybe blindly you can go for T3 and T3, but you should know like how you can approach that question. Fine. Okay. With looking option and with looking the regular expression, yes, you can go. Okay. See, clearly type checking is done before parsing. No, after parsing. You know, after parsing. In semantic analyzer we do type checking. Okay. High level language programs can be translated into different intermediate representation. Yes, this is also true. Fine. We have different intermediate representation like postfix notation. We have what DAG notations. We have what 3 address code notations. Fine. Everyone know. Argument to a function can be passing using the programmist text. Yes, in activation record. If you know about the activation record, yes, argument to a function can be passed using the programmist text. So that is also true. So the option is what? B for Bombay is incorrect. Okay. Now for this one, consider the following statement. Okay, so they have asked here, consider the following statement. Can you please tell me what is the correct answer? They are asking about true. They are asking about true, my dear friend. Asking about true, my dear friend. What is the answer? Okay, someone telling B. Someone telling B here. I think for last question you are telling might be. Okay, can you please give me the right answer? Simple table is accessed only during the lexical analysis and syntax analysis. No, all phases of the compiler. This is false. This is false. Fine. Compiler for programming language that support recursion necessarily need heap storage for memory allocation in the runtime environment. No, it will also use stack. Fine. It is not necessary they will use only heap storage for memory allocation. It might use stack also. That is not guaranteed. So this is also false. Error violating the condition. Any variable must be declared before its use or detected during syntax analysis. No, semantic analysis. Using semantic analysis, using CSL you can do. So I think true they are asking. So none of the above. None of 1, 2 and 3. I think this option is not hidden up. Fine. So none of the above. None of the above. Means koi bhi true nahi hai. All are false here. All are false. Okay. All are false. I will maintain by tomorrow, my dear friend. Fine. Definitely. Okay. Now see clearly this one. This question. So in this question, there are 4 options. One is lexical analyzer. Second one is machine independent optimizer. Third one is semantic analyzer. Fourth one is syntax analyzer. Fine. Fourth one is what? Syntax analyzer. D. Syntax analyzer. D, yes, D is what? Syntax analyzer. D is what? Syntax analyzer. Okay, for the last one, if you are talking about last one, my dear friend, if someone have doubts, last one all are wrong only, na? All are wrong. Third is also false, na? They are telling error violating the condition. Any variable must be declared before its use are detected during syntax analysis. Semantic analyzer will take care of it. Fine. Okay. Now this one, my dear friend. See, D option is what? Syntax analyzer. So see clearly they have given int main. Fine, integer x return 0. How many tokens are there? If I'm asking how many tokens, क्या ये token provide करेगा? क्या ये token provide करेगा? It will give the token or not? It will give the token or not? Can you please tell me? It will give token or not? Can you please tell me, my dear friend? It will give token or not? See, it will give token. Number of tokens, see clearly. Int is identifier 1. Main is identifier 2. 3, 4, 5. Fine. Integer is an identifier. This will work as an identifier. 6, 7, 8. Fine. 9, 10, 11, 12. Here we have 12 tokens. Fine. Here we have what? 12 tokens. It will not give lexical error. It will what? You are able to count the tokens. It will not give lexical error. See, lexical error कब देगा? देखो, हर एक प्रोग्रामिंग लैंग्वेज का अपना एक लिमिटेशन होता है ना, लिमिटेशन होता है. आर यू गेटिंग माय पॉइंट? like Python will count certain number of identifier, C will count certain number of identifier, ANSI C will count certain number of identifier. Are you getting my point? If we have maybe some illegal constant, like in constant we have some like you can say special symbols, if you insert, it will give error, lexical error it will give. It will not count tokens. Or maybe some like illegal notations, like let's suppose you have declared this and here you are writing dollar like this. Let's suppose in program dollar is also there. So might be it will give error. Might be it will give lexical error. It will give lexical error. Fine, but here it will not give any kind of error. It will not give any kind of error, my dear friend. Fine. See clear? Sir, ID है. Sir, ये देखो, see what is happening actually here. Int is what? Int is what? Keyword. Okay, let me. Int is what? Keyword. So KW I am writing keyword. After that, what we have? Main is identifier. ID1 I am writing. This is what? Let's suppose special symbol. SP1, SP2, SP3. Fine. Opening braces. Integer. This is what? Identifier. ID. ID what? ID2. Then what? ID3. ID3. See here. Identifier. Then what we have? Special symbol. SP4. Fine. Now what we have? Return. Keyword. So keyword 2. Fine. Keyword. Constant. Fine. Whatever you can say. Let's suppose C1. And what we have? Special symbol. SP1. And what we have? So not SP1. It is SP5. SP5. And we have what? SP6. Are you getting my point? So that will be the output. It will look like this only without any white space and all. So my dear friend, it will not give any lexical error. So see, even though we have ID here, fine. There, see, it will not come in lexical error. But my dear friend, see clearly. Now, in GATE they have given the answer is semantic analyzer, and what they have given कि integer is not, जो integer है इसका कोई type नहीं है, मतलब integer is not defined. Fine, integer is undefined. But this one also gives syntax error. But see here, for this one we don't have anything. Fine. ID2, ID3, ID. See here, ID and ID, my dear friend. So it might also give syntax error. But in option in GATE, theoretically if you give, theoretically also if you go, it will also give syntax analyzer, syntax error also. Fine. But in GATE they have given semantic analyzer. So अगर आप GATE के साथ जाना चाहते हैं तो आप semantic analyzer टिक कर सकते हैं. But yes, it will also give syntax analyzer. Fine. Syntax analyzer. Maybe see here, you can, if I will write z equal to x plus y, you can find number of tokens here. You can find number of token here, like 1, 2, 3, 4, 5, 6. But it will give syntax error. It will give syntax error. Are you getting my point? Okay. Is that clear? Fine. But like, why it will give syntax error? But because you are not able to draw the syntax tree for this. If you are not able to draw the parse tree for this, it will give syntax error. Okay. मैंने गलत तो लिख दिया? Yeah, I think it is fine. Okay, is that clear, my dear friend? Please reply. Please reply. Is that clear? I think I have written wrong. I think you can write x plus y equal to z. Is it so? Okay, which one will give syntax error? Z equal to x plus y or x plus y equal to z? Is anyone will give error? Is anyone will give error? Please reply fast. Anyone? Order of tokens is taken care of syntax analysis. Yes, see, stream of token as an input. Syntax analyzer, for what we have a stream of tokens. And with the help of a stream of tokens and CFG, we are able to generate the parse tree. If you are able to generate the parse tree, it means there is no syntax error. But if you are not able to generate the parse tree with the help of syntax tree or with the help of context-free grammar, it means there is a syntax error. So see, if you are not able to generate the parse tree, it means there is a syntax error. Fine. So for this one, what I'm telling here, ID we have. So that kind of thing also, like, it will give syntax error because you are not able to generate the parse tree for this. Fine. So between two ID might be we have some operators. So it might be have give syntax error also. So in this question, like, we have both syntax error and, my dear friend, and we have what? Semantic error. Fine. So error will be give on syntax and semantic also. Is that clear? See, what will happen if you see the example of lexical analyzer. So lexical analyzer and syntax analyzer. So what will do? It will produce token and it will ask for the token. And with the help of that, you are able to generate the token. Fine. Whenever syntax analyzer want token, lexical analyzer will generate the tokens. And with the help of that, we have a CFG. We have some rules. With the help of that, we are able to generate the parse tree. Is that clear? Fine. Okay, shall I move now? Okay, I'm moving now. Okay, so what is the answer for this one? In the context of compiler, which of the following is not an intermediate representation of the source program? Not an intermediate representation. So 3 address code is an intermediate representation. Control flow graph also, an abstract syntax tree also. So D is the right answer. Symbol table. It is a data structure to store variables, user-defined function, user-defined variables into the symbol table. Fine. So yeah, symbol table is not the intermediate representation of the source program. We have different kind of representation, like we have postfix, we have DAG, we have, like, we also use control flow graph, fine, for the optimization. Abstract syntax tree, it is a form of, like, you can say syntax tree only, fine, where we have what, like, we have operators, we have internal node and roots are the operators only, fine. So yes, 1, 2, 3, fine, you can represent, but yeah, symbol table is what? It is not the representation of the it is not the representation, fine, of intermediate code. Okay. Yeah, D is the right answer. Okay. Now you can tell this question. Consider the following statement regarding the front end and the back end of the compiler. They have given the front end includes phases that are independent of the target hardware. Fine. Now the back end includes phases that are specific to the target hardware. And the back end includes phases that are specific to the programming language used in the source code. So which of the following is correct, they are asking. So option A, I am telling here, statement 1 is true. Option B, S1 and S2 are true. Option C, all are true. Option C means all are true, all true. Option D is only S1 and S3 are true. Option C, all true. C, all true. And option D, my dear friend, option D, only S1 and S3 true. Only S1 and S3 true. Can you please tell me? Everyone, please reply fast. Okay. So someone telling B is the right answer for this one. Yes, B is the right answer. See, the front end include phases that are independent of the target hardware. Yes, that is right. That is right, my dear friend. So till intermediate code generator, it is nothing but front end. And from one front end, we can generate many backends. So my dear friend, the front end includes phases that are independent of the target hardware. That is what true. That is what true. For one front end, we can generate many backends. Many backends, my dear friend. Is that clear? We can generate many backends. Okay. Now, the back end include phases that are specific to the target hardware. Yes. So this one is what? S2 is what? True. The back end, it is what? True, my dear friend. Fine. S2 is what? True. S1 is also true. Fine. Now, see, the backend includes phases that are specific to the programming language used in the source code. No, this is absolutely false. Fine. It is not a specific backend. See, it is not specific to the programming language. It is what is specific to the what processor you are using, what architecture you are using. Suppose one is using, let's suppose Intel, one is using AMD processor. So it depends on the architecture. It depends on the architecture, not depend on the programming language. Fine. So that's why it is false. That's why it is false, my dear friend. Fine. So this one for answer is what? B. Okay. Now you see clearly here, till this one is nothing but we have front end, and this is nothing but you can say back end. Back end, my dear friend. Back end. Are you getting my point? Back end. Is that clear? Please reply. Please reply, my dear friend. Fine. So from one front end, we have what? Many backends. From one front end, we have what? Many backend. Is that clear, my dear friend? Okay. Okay. So see clearly here. Let's suppose if we have four different machines. See M1, M2, M3, M4. If I'm asking you, see here. So see till this one, it is same for every compiler. It is same for every compiler. Are you getting my point? Same for every compiler. Lexical analysis, syntax analysis, semantic analysis, ICC. Fine. We need to change what? Only target code generation and code optimization part only. Fine. So see here in some books, we have what? Machine independent code optimization. We have machine dependent code optimization also. So if you want, you can write here. Fine. If you want, you can write here. Fine. Okay. So yeah, in class, we have discussed this one, like this was, we can discuss more, but here we are only solving the problems. Fine. So if you have doubt, definitely you are able to ask. Like, I think in Java, we can generate bytecode now. We can generate bytecode. That's why it is what? Platform independent. But in C, there is no concept of bytecode. It is what? Platform dependent. Fine. Compilation till here. Fine. In Java, maybe compilation till here only. Fine. Okay. So I think we have done all the questions of lexical analyzer. Fine. So tomorrow we'll do question on grammar, maybe ambiguous grammar, unambiguous grammar, and we will do question on left factored grammar, left recursive grammar. Fine. So, and we'll see how to convert any ambiguous grammar into an unambiguous grammar. There is no algorithm to convert ambiguous grammar into an unambiguous grammar. Fine. It is you can say there is no algorithm like to find also like this grammar is ambiguous. Fine. There is something called, you can say, if the grammar is both left and right recursive, it is ambiguous. Fine. But there is no such algorithm who can tell you whether the grammar is ambiguous or not, or whether you can convert any ambiguous grammar into an unambiguous grammar or not. Fine. So tomorrow we'll see. And tomorrow is on app, my dear friend. App. It is free for everyone. CS app free live BYJU classes. Description दिया हुआ है, ठीक है, लिंक आपको, ठीक है, आप वहां से उसको BYJU ऐप को डाउनलोड कर सकते हैं. आई एम स्टार्टिंग ऑपरेटिंग सिस्टम. फाइन. आई एम स्टार्टिंग ऑपरेटिंग सिस्टम. So I will take 2-day class of CPU scheduling and 2-day class of synchronization and 2-day class of 1-day class of deadlock and 1-day class of memory. Fine. After that, we will also take 1-day class of memory. Fine. This is the structure of 6-day. 23, 24. We don't have class on 25. So 26, 27, 28, and 29. Fine. If you are with me, definitely you are able to solve. Definitely you are able to solve the problem of my dear friend ऑपरेटिंग सिस्टम. फाइन. शेड्यूलिंग तो पक्का है, बहुत आसान होता है. सीपी शेड्यूलिंग मतलब बहुत आसान होता है. फाइन. इफ यू आर लाइक you cannot miss, my dear friend, CPU scheduling at all, because they will ask easy question only, very easy question. But synchronization, they will ask tough question also. They will make very good question also. So definitely I will make it easy for you, if you know all the algorithms, because they will change the algorithm only. They will change the log variable, they will check the strict alternation, they will check the Peterson algorithm, they will change the producer consumer problem, they will change here and there in the code, and they will ask you whether mutual exclusion satisfy or not, progress satisfy or not, bounded weighting satisfy or not. So we'll see this one, and we'll see deadlock also and memory also. Tomorrow 7 p.m. you can join the BYJU app. Fine. Description के अंदर link दिया हुआ है. Fine. And this is, my dear friend, test series. That is very, very important. I told you this is only for the motivation purpose. I am telling you. And see, BYJU test series is also very good. If you want, you can join this. And this one will definitely boost up your confidence also. Fine. And yeah, on 24th September, fine, you can join you can give the scholarship test for maximum discount. And also we have we have a workshop, and Richa Gupta ma'am will take care of this one. Fine, on 27th September. So last 120 days preparation strategy to ACE Gate 2024. So how you can prepare in 120 days? Fine. What is the strategy? It is also very important. If you want, you can join this session. So thank you so much. We'll see you tomorrow. Already Gate crash course has been started. If you want, you can join. I am taking DBMS. Fine. As of now, I have started DBMS. Fine. You can join. Limited seats are available. Okay. So this is my Telegram link. You can join this Telegram link, and you can ask question there. Fine. Definitely. This is what you can ask question. Definitely, I am able to solve your problem. Fine. If I will be happy to solve your problem, my dear friend. Fine. So thank you so much. Fine. Please like this and please do subscribe the channel. अगर आपने subscribe नहीं किया है, fine, and please like and share. अगर आपको अच्छा लगा हो तो. We'll meet tomorrow same time 9 p.m. on YouTube. 9 p.m. on YouTube, same time. Fine. Every day 9 p.m. Fine. 6 दिन लगातार शो चलेगा कंपाइलर डिजाइन का. 6 दिन में एटलीस्ट कंपाइलर आप प्रॉब्लम्स कर पाएंगे. So 9 p.m. tomorrow I will meet you, my dear friend. Please be there. And 7 p.m. on BYJU app. OS, and this is CD, and tomorrow we'll solve more problem based on grammar. Thank you so much. Take care of yourself and your family. Bye bye. Good night.